Okay. I returned your quizzes to you. There are some problems that I want to go over in terms of the types of problems that I think the biggest thing was just not exactly sure which quadrant you're in, and so a lot of the negatives and positives got mixed up. And then also, problems like these where you had to find, given that, sine is less than 0 and cosine is 5/12, to be able to find the ratio. Also, anytime you have any trig function that is undefined or 0, that it's going to be along your x or y axis. So they're just dealing with those order pairs. So I'll get to that after a little bit. But on page 40 are the non-calculator section. So this is page 40 is pretty much what you did on the quiz yesterday, right? So nothing new there. So let's spend time first on page 41, which is the calculator stuff. And you probably want to see if you can bring out your old quizzes and just look through those problems as well, because your test tomorrow is just a combination of problems that are from your quizzes. Okay, so nothing new, but it's good that we review some of the older topics that we haven't seen in a while. So page 41. Okay, so number 1 says convert 260 degrees to radian measure. So if I'm in degrees, how do I convert to radian? Yeah, times pi over 180. Make your calculator do the work. 260 divided by 180. Leave pi out of the calculator. You're just going to attach pi once you get that ratio figured out. $60 divided by 180 gives me 13/9. Pi over 9 radians. Okay, likewise, converting radians to degrees. How do we handle that? Yeah, 180. Pi's cancel out. Do 25/2, or if you want to get it down to a decimal value. Okay, number 3, state the quadrant of the terminal side and find its reference angle. So again, the way we deal with the reference angle is we find the closest x-axis, and then we either subtract involving 180 or subtract involving 360. If you're in the second or third quadrant, then you're going to be subtracting from either pi or 180. If you're in the fourth quadrant, you're just going to be subtracting from involving 360 or 2 pi. So number 3, which quadrant are we in here? 105 degrees is in quadrant 2. Okay. So quadrant 2, you know that you're going to be involving 180. So -180 minus 105. And that prime just indicates that we're talking about reference angle. Okay, -310. If you don't recognize the degree measure, what can you do to make it more recognizable?
Add up 360.
Add 360. So if something's in the first quadrant, do we need to make any adjustment for reference angle? No, it's the same, right? Reference angle is just an angle between 0 and 90. So if it's already between 0 and 90, there's no need to adjust. Okay, 9 pi over 5, it's not a special angle, or it's not on the unit circle, but which quadrant is 9 over 5 pi going to be in? Fourth quadrant, okay? And the reason why is because you look at the fraction, leave pi out of it. 9/5 is less than 2, but greater than 1.5. So you know it's in the fourth quadrant. So if something's in the fourth quadrant, yes, question?
How did you find the reference angle?
Right, so what's the definition of
It's supposed to have axis.
yes, close to x-axis. The close x-axis is 0, so 50 minus 0 is just 50. Okay, good. Number 5, yeah, so quadrant 4. So if our measure is in quadrant 4, how do we find the reference angle? Yeah, we subtract involving 2 pi, right? Because we know that this is what's happening. We know that 9 pi over 5 is somewhere in the fourth quadrant. If I want to find my reference angle, I'm going to subtract from 2 pi to get that reference angle. So 2 pi minus 9 over 5. Use your calculator or find common denominators. Okay, any questions? Page 40, 1 through 4 on page 41. Okay, number 6. This is a Pythagorean theorem, or this is, sorry, this is a right triangle trig problem. We draw a triangle and we have to figure out either a missing side or missing angle. So number 6 here. Distance measuring equipment, standard avionic equipment on a commercial airplane. This equipment measures distance from a plane to a radar station. If the distance from the plane to a radar station is 220 miles and the angle of depression is 38 degrees, find the number of ground miles from the point directly below the plane to the radar station. So I'm going to draw a triangle here. We have the plane, the radar station. Distance between the radar station and the plane is 220 miles. Angle of depression is 38 degrees. Okay, where do we put the angle of depression?
At the top.
Bottom, same spot as angle of what? Elevation. And the reason why we do that is because angle depression is kind of misleading because it is angle of top, but it's an angle that's outside the triangle, at least the way that we draw it. So to ensure that that 38 gets in the right place, we never want to put it inside the triangle here. We're always going to put it in the same spot. So it's confusing because it would be easier if the problem just said the angle of elevation is 30 degrees from radar station, but it's saying it's from the plane's perspective. But you're just always going to put it in the same spot. If you draw a triangle this way, it's going to be the same spot as angle of elevation. So don't let that angle depression throw you off. Okay, find the number of ground miles from a point directly below the plane to the radar station. So what's the missing side that we want to look for?
The base.
The base, good. And the key word here is ground miles. So ground miles means, if the plane was on the ground, how far would it travel? So it's talking about the horizontal distance. So the hard part of this problem is just setting it up. But then once we get it set up, we can identify the trig function and set it up and solve for x. So we know we're looking at our triangle from the perspective of that 38 degrees. So which trig function do we want to use? Cosine. Yep. So set it up. Cosine of my angle adjacent over hypotenuse. Cross multiply, solve for x. I would say either 2 or 3 decimal places. If it doesn't say anything, but if it does, then we'll specify. Okay. Any questions so far? Okay, number 7. A pendulum is 22.9 centimeters long. So let's draw pendulum and then the bob at the end. And the pendulum is something that swings back and forth. Okay, so we know that as it swings back and forth, I have an idea of the path of its movement. Right? So it's going to kind of move in an arc. Kind of go back and forth. A pendulum is 22.9 centimeters long. So we go ahead and put that down there. And then the bob at the end travels 10.5 centimeters. Now, the travel is along a curve. So what does this remind you of? This is what formula we're going to be using here. Remember, S equals R theta, right? This is arc length, right? So arc length is, what is the length along a curved path? So S is the arc length. R is the radius. Theta is the angle, but what do we have to be careful about with the angle? It's always in terms of radians. Okay, so either you put something in terms of radians or whatever returns back to you is in terms of radians. If you want to do degrees, you got to convert it outside of this formula. Okay, so let's assign some values here. Pendulum is 22.9 centimeters long. What do you think that represents? The radius, right? So imagine this is a portion of a circle, and then that 22.9 is from the center to a point on the circle. So that's your radius. Okay. The pendulum travels 10.5 centimeters. That's the arc length, right? That's the length that it travels along a curved path. So arc length is 10.5. It says find the degree measure. So we're going to find theta, but remember theta is in terms of radians. So we're going to do the degree measure later, right? But one thing at a time, let's find theta first. So I replaced S with 10.5, replaced R with 22.9, and now I want to solve for theta. So how can I solve for theta? Yeah, get that theta by itself, move that 22.9 to the other side. Use your calculator. Theta equals let's say we round to 3 decimal places. What do we get? Yeah, either 0.458 or 0.459. Either is fine. Now, this is in terms of what? Wait. Radians, right? Anything with a formula is going to be given to you in terms of radians. Is that clear? Right? If you're touching the formula, then theta is going to give you in terms of radians. Degrees, we got to do something else with it, but are we good with theta equal 0.459 radians? It doesn't have to be. I mean, you could leave it as a fraction. I just decided to get the decimal version. But you could have left it as 10.5 or 22.9. I guess that's more accurate. But I do want to point something out here. I saw a lot of mistakes on the quiz when students got to this point. You know what a lot of us wanted to do to adjust with that theta? Any idea? So here is what I see. I see a lot of students wanting to involve pi in the calculation because I think a lot of us associate pi with radians. So I see students do this. They attach the pi because they're like, well, it's a radian measure, so I'm gonna have to include it. Now we don't want to do that. Okay, if it has pi in it, then we leave it, but we don't want to add something that's not part of that measure. Okay, so theta is just 0.459. Okay. If there's a pi involved, then it would have shown up at the beginning and it would have shown up for you. But we don't want to, multiply our answer with 2.14 just because it looks more familiar, right? It's not quite right. So we're sticking with a 0.459, but is it in the proper units that we want? It's in terms of what? We wanted to get from radians to degrees. So how do we convert from radians to degrees? Times what? 180 over pi. So I think this is where we run into some issue. I think this is the reason why a lot of students wanted to include the pi, because they're thinking, okay, I got to cancel that pi out. So why don't I just put a pi here, and that way the pi cancels out. The radian measure is already here. The pi, it may not cancel out. It's, if it does, great, but if not, then we just multiply this out, right? So we don't want to overthink it and just force the pi into a problem that's not part of the problem. So the conversion from radians to degrees is just times 180 over pi, regardless of what you see here, right? We don't want to make any changes to whatever is already on radian. So we enter this in the calculator. What do we get? I got 26.298. Okay. got it. So if you're holding on to this value, then yeah, that's gonna be more accurate. If you kept this fraction, okay, let's do that. Let's keep that fraction. And go directly into multiplying by 180 over pi. And that's gonna become more accurate. Yeah, 26.271. Yes.
Is it fine if we do either?
Yeah. I'll be okay because I'm more concerned about your steps and that you understand what's going on. So if you round it halfway, because this is cumbersome to work with, I'm okay with that. But are we okay with what happened here? Now, what I see some students do when they get to this process, I see some students either multiplying by the wrong ratio, either pi over 180, or they do 180 over pi, but then they just multiply by that 180 and then they attach pi to the end. You want to enter this whole thing in the calculator. Okay, the pi is it's just not going to stay. Especially if you want to get something that is numerically recognizable. So, yes, question. No. Yeah, so you're gonna have to create your own unit circle again. Yeah. I'll give you a blank one. Yeah, give you a blank one. But hopefully we're to the point where, we're able to create it within a few minutes. Okay. Yeah, I'll give you a blank unit circle tomorrow. And then that blank unit circle, I'll put on a separate page because to begin with, you're going to be starting off with the non-calculator portion, and then I'll have that unit circle on a separate page, and then you're going to turn in your non-calculator portion. Then I'll give you the calculator portion on the different color sheet, and then you can bring your calculator out. Then you can also have that unit circle sheet with you. Yeah.
How many questions are going to be on the test?
The test is going to be 2 pages. So 1 page will be calculator and second page will be non-calculator. So pretty much the length of what you see here. Okay. So page 40 and 41, that's what you can expect. Now, I gave you also a morning test review that you just picked up. And I will have a morning help session tomorrow, 7:15, going over the full review. So if you want to come in and join me for that, you can. But I'll also send out a Teams link if you want to join on Teams, or you can just work it through. I have the key attached, and if you can do everything on your own, then there's no need for a help session. You should be prepared and ready for tomorrow. Okay. I do want to point out one more type of a word problem with you. So yeah, so on the other packet, I put some more word problems towards the back. So and it's the ones involving the 2 triangles, the double triangles. I want to make sure I go over that. This is so does everybody pick up a packet? Okay, so if you flip through, yes. Yeah. If you flip through the packet, I put some double triangle word problems. Let's look at this here. And that attach the key as well. So I'll do one with you, but then the others you can kind of just work through on your own, make sure you're comfortable with these types of problems. Okay, radio station tower was built in 2 sections from 0.87 feet from the base of the tower. The angle of elevation is 25 degrees. And then to the top of the second section is 40 degrees. It says to the nearest foot, what is the height of the top section of the tower? Okay, so we always want to force two triangles out of this. We don't want to try to do too much at one time. So I'm going to draw two triangles separately. So one triangle I'll highlight in yellow, and the second triangle I'll highlight in green. But okay, so let's draw the two triangles. So we have the smaller triangle, and then we have the bigger triangle. Let's use different variables. Let's say that this is y. Let's say this is z, so that we don't conflict with the x here. Let's fill out as much information as we can for both these triangles. What angle can I put inside the small triangle? 25. Okay. What other information do I know about this triangle? Yeah, the base, right? The base is 87. Okay, we'll come back to that. Eventually, we'll solve for y. But let's go to the second triangle here. Okay, what can I put in for that angle measure? 40. And again, the base is 87. So if I can find y, if I can find z, then I can involve these two sides to figure out what this missing distance is. So let's solve for y and z separately. What trig function can I use to get to y and z? Tangent, right? Because tangent is going to allow me to do opposite over adjacent. So cross multiply, solve for y. All right, so separately, we can solve for z. So set up the same way, right? Multiply. So if I know the big to the very top is 73.002, and the distance from the base to the smaller tower is 40.05.569, how can I use these two to find that difference here? Subtract, yeah. So the height of this big triangle minus the height of the small triangle will give me the difference. So if you ever see a triangle within a triangle problem, force yourself to draw two triangles, solve the missing side independently, individually, and then usually you're just going to be involving subtracting those two values to get what you need. Okay. Let's go to page 40. And just get some more practice working through. Then have your unit circle out and work alongside your unit circle. And I'll work through each problem as you guys try them. Okay. Yes. Yeah. Any questions with 1 and 2? Now, I saw some students having some trouble with a problem like number 3 on the quiz yesterday. If you're having trouble deciding where that point is, just go ahead and plot that point on the coordinate plane. Okay. So if I asked you to plot 5, -12, what would you do? You would go 5 units to the right. And then you would go down 12, right? So that's going to automatically land you in the 4th quadrant. You don't have to do anything special. If you just plot that point like you normally would, it'll land in the quadrant that you're supposed to land in, right? So you're gonna go 5 over and 12 down. Once you plot point P, or whatever that point you want to call it, you can draw the triangle from there. So go ahead and plot that point first, and then ask yourself, how am I going to get there? I got to move to the right 5, so that's positive 5. I got to go down 12, so that's negative 12. And now I can use Pythagorean theorem, and I can find my missing side. Remember, your hypotenuse is always positive. So now that you have everything in front of you, you can find the ratio for sine, cosine, and tangent. Any questions with 3? Okay, number 4, state the quadrant in which theta lies. Sine is negative. Cosine is negative. Let me do this ASTC, and let's start eliminating my options. So where is sine going to be negative? 3 and 4. So I know I'm down to 3 and 4. I can remove 1 and 2. And now, just looking at third and fourth quadrant, where is cosine going to be negative? Third or fourth? Third. So you're in the third quadrant. Try the other ones. For cotangent, I chose the easier one to recognize, which is tangent. Tangent is positive in the first and third. And between first and third, the only place that cosine is positive is in the first quadrant.
In B, it says tan is negative.
Oh, sorry, my bad. Thank you. Try that again. So sine is positive in the first and second quadrant. And between the first and second quadrants, where's tangent negative? It's going to be with the second. cotangent positive, cosine positive. Tangent is positive in the first and third, then cosine positive first quadrant. Okay, okay, just like number 4, we're going to find which quadrant we're in. Recognize that these are not unit circle values, so we're gonna build a triangle and find the missing side. So tangent is negative, sine is negative. Tangent is negative in the second and fourth. And between the second and fourth, sine is negative in the fourth. So we know we're going to be drawing our triangle in the fourth quadrant. So this is important here because we know that we're in the fourth quadrant, we're now going to know where to put the negative, right? Because right now it's not really telling us where that negative is going. Is that negative going with the 15 or is negative going with the 8? Well, let's fill in the 15 and 8 first. Tangent is opposite over adjacent. So where's the negative going to go? Is it with the 8 or was it with 15? 15, right? So it's kind of being, purposely vague to see if students are able to find the appropriate place where it belongs. So that negative goes with the 15. Okay, Pythagorean theorem will get you to your hypotenuse. Says determine the sine and cosine and tangent. It already tells us what tangent is, so we should find sine and cosine. Okay, part B, secant of theta equals -2. So this is a strategy that we can do as well as maybe this is a unit circle value, but maybe we can create the reciprocal version, right? Because if secant is -2, then what do we know? What's related to secant? Cosine must be what? -1/2. And maybe that's a little bit easier to start from. Maybe we, but we can, yeah, so that's a strategy too, that if you see something that is given to you in terms of one of the reciprocal trig functions, then get into something in terms of sine, cosine, and tangent, and that feels more recognizable, right? Cosine is -1/2. We can find that on the unit circle. It says to look just between first and second quadrant there, between 0 and pi. So which quadrant are we going to look at? So that cosine is -2, right? So we know we're in the second quadrant. We find that order pair. And then we can find sine and tangent from that order pair, right, in the second quadrant. Tangent is just y/x, cover up the 2, and do √3/-1. Okay, part C. Sine is equal to 0, secant equals to -1. Okay, so anytime I see anything equaling to 0 or undefined, I know I'm just dealing with what? Just the axis, right? Those are the only things I need to worry about. So I'm just gonna write down all the order pairs just so I can quickly eliminate the ones that I don't have to worry about. Just focus on the one that I'm gonna deal with. So sine is equal to 0. And sine is related to what? The x or the y? The y. So where is y gonna be 0? Either -1, 0 or 1, 0. Okay, so we know we're down to those two options. Secant is -1. Secant is related to the what? Cosine. If I flip -1, I still get -1. So I know that my x is -1. So it has to be this point, right? So now that I have my order pair, I'm going to find my sine, cosine, tangent. I already have my sine. My cosine is just my x. And what's tangent going to be for this order pair? What's the formula for tangent? Y over x. So 0 over -1. Now I want to make sure that we understand what this is. What's 0 over -1? 0, right? If it's -1 over 0, then I say that it's undefined. Okay, so if you tell me just 0 over -1, I still want to see 0 because I want to know that you understand what this means. This is not undefined. So 0 over a non-zero is 0. But if I have a non-zero over a 0, right? I can't divide by 0, so that's where that undefined comes from. Yes. Yes, but look at the restriction. It says between 0 and pi. So we're just looking at the first and second quadrant. We're not looking at the third and fourth. Okay, I encourage you guys to work through the rest of this. I have the key on my website under today's date. But I will have a morning review tomorrow. And but I encourage you guys just to work through it, because if you can work through it on your own, and I specified on the morning review which one is calculated and which one is non-calculated. Okay, so if you can work through that on your own, you should feel comfortable for the test tomorrow. But we'll do the non-calculator first. I'll give you a blank unit circle. You can fill that out, and you get to keep that blank unit circle even when you turn it in and take the calculator portion. I think you can.
No, I started a research point. It's like, I started a research point.